Welcome back to the Object Stacking and Packing tutorial series. I'm your host, Thomas Tobin. If you haven't seen the previous chapters, I recommend going back to find them. In this episode, we will be focused on setting up the packing portion of this tutorial. Hope you enjoy. For the next part of this tutorial, we're going to create an object that we can place these objects into. So this is our placement volume. So I'm going to quickly create an object merge. And now this would be the input from your box brush, for example. And you probably want to promote this, again, to be a parameter. For now, inside Houdini, I'm just going to quickly make an object that we're testing all of this within. So I'm going to poly extrude. I'm just going to choose one face. There we go. So we have a basic object, and this would be your BSP within Unreal Engine. I'm going to link this null. So effectively for our HDA, we would promote this up as the box brush that Unreal Engine would use. But for any other tool, it's pretty much the same workflow. You would create an object and then be scattering the objects within this. So we need to figure out the scattering area that we can actually use. And so I'm going to assume all the objects you make are flat. So this flat level at the bottom, we just need to grab its normals and delete everything else. So I'm going to put down a group node, keep my normals. I'm going to select the bottom face, so that's direction is -1, and lower the spread angle. So you can see we are selecting the bottom. I'm going to blast away anything but that group. So now we're left with just the bottom face. I'm going to do a reverse node just to have the normals facing upwards. And this is pretty much the null. I'm going to put down a null just for organization. Out bottom layer. Now, if we want to do any processing, we can just put it above the null. And when I reference this later on, if I do, I can just go to the end of basically the processing of the bottom layer. So the first thing we need to do is place down a scatter align node. Now the scatter and align node is pretty much powering all of our placement for this tool. The node gives us points on top of our mesh and sets up all the attributes we need for this tool to work. I'm going to change the point cloud method to by density. And this is going to allow me to increase the coverage or decrease. I'm going to set to 1 right now. And also have a set density scale. I'm going to make this number pretty large. I'm going to say 300 or something. And so that's going to give me, down at the bottom, you can say 3,000 points, which maybe is quite a lot. Let's go to 150, 100. Yeah, 100 is good for now. And the higher this number goes basically means it's going to try and put as many objects in the space, but it's not going to try and pack them. And so we're going to just fill the space and then almost pack with the angles that it's setting, the ones that it can, and then we're going to get rid of the ones that can't fit. So once we place down the scatter and align node, I'm going to put down an attribute randomize. And this is basically how we're going to define on each point, which object should it place? Again, that's your variant. So we're going to randomize variant. And I'm going to make it a uniform discrete value. And this is going to allow me to set a min max number. And the max is how many total objects do we have? And so we actually came up with the attribute earlier. And so that attribute is we go back up, I believe it is our attribute promote class, our maximum number of classes. So I can simply link those two together, and I'm going to do a add spare input and then drag our input to scatter into this. So now you can see a purple line just saying that these two nodes are referenced. And I'm going to have the scene reference function, scene data, sorry, figure out the formula for me. And I really want to push this feature of Houdini because oftentimes you have to memorize these, and over time you will learn them. But there's so many different ones. It's so handy. You can just go to scene data, select the node you're trying to reference, and it brings up all the attributes, all the nodes, and does all the typing for you. So this is something that's super useful. Input to scatter. It's right here. And then attributes, global, and we have our max value. The last thing I'm going to change is the input to scatter node. I'm just going to change that to our -1 reference, just to keep it nice and clean. I can see which functions are using the spare input. Now this is set 0 to 2, so that's the same value as our max number. And our stepping size pretty much allows us to say how many do you want to step by. So if you step by 2, you could skip some of the objects. So a way to reuse this tool in the future, not just for boxes, if you filled up your list with, let's say, 10 to 15 objects, you could say, I just want objects 5 till 7 in this area. But in another area, you want objects 10 to 15. And so that can add really quick variety just by simply setting a unique min and max value or varying the stepping size. So now that we have our variant on here, I'm going to place down a copy to point node. Now, the geometry that we're going to be copying is not this point. We're going to be copying to these points, of course. And what we're copying is the input to scatter. So I'm going to connect that over and connect our target points to copy to our attribute randomize. Now, when we view it, you can see we're copying to each point. However, we're not using the variant yet. So I'm going to turn on piece attribute, and we get an error. Target piece attribute is a floating point attribute. It must be an integer or string attribute. So it's ignoring it. What does that mean? Well, if we go back to our attribute randomize, we can see our variant is a float, and it's asking for an int or a string. So a really quick way of fixing this is put down an attribute cast. And now you're able to convert that float to a int. So I'm going to do variant to a 16-bit integer. Now, ta-da, our data is working. The next thing we have to fix is our rotations. So inside the scatter line node, like I said before, has a lot of the parameters that we need. If you change the min and max angle, you can see very quickly it's setting up all our rotations for us. Having a round to multiple of, saying set to 15 degrees, will keep them all within a similar angle range. So 45, they're either going to be 45 degree, 90, they're going to be aligned. And so you can kind of create unique variation within this node too. So I would recommend you find a value you like. Right now, I'm going to keep this off. But in the very final HTA, pretty much you just want to expose every single one of these as a parameter that you can use. So you can see we're filling the space, but the objects are quite small. Now there's a couple things that affect this. If we go to our object output placement and we put down a transfer node, scaling this value is going to make the surface area smaller, but you can see the objects are actually scaling with it. Now this is due to the density scale on the scatter, on the scatter line. So I'm just going to connect this back. Now if we directly affect the density scale, you can see as it gets to a smaller number, those objects change in size. So this density scale value you have to be quite wary with because it's affecting the actual, as it says, density scale. And so kind of one thing I would want to expose is probably higher up. And that's going to be on our original geometry that we're copying into the scene. I would put down a transform node and have this controlling the size of your objects. So if we go to our copy to point and I go to that transform node, now as I scale those objects larger, within the scene, nothing else is changing but those objects, which is perfect for this use case. So I'm going to set it to something like a value of 3. And I'm just eyeballing that figure. That's no particular reason why. The next thing we have to do is, if we middle click on this copy to point, we're losing the attribute orient. So this is something I want to copy over. So we want to know the orientation of each of these points. And that's very useful for later on. So I'm going to put down attribute transfer. And I'm going to transfer onto our copy to point. The final thing on this copy to point, to keep efficient, I'm going to keep this pack in instance. So now we have our 6 point attributes, and before we had our 6 point attributes. So it's all staying in line. The next thing I want to apply is scale. So how can we change the scale on each of these objects? Because right now, all of the pink boxes, green and the yellow or green, are all the same size. So I'm going to put down another attribute, randomize. We're going to use a preset attribute called iScale. Again, I'm going to set the dimensions to 1 and use a uniform discrete value. This is going to allow me to set a stepping size like we said before. And the stepping size basically changes how much this number kind of steps up by. So if it's stepping size 1, it's going to go 1, 2. If it's a small stepping size 0.5, it's going to go 0.5, 1, so on. So I'm going to set this relatively small right now. And I think I'm happy with this right now. And if we look at CD, if we visualize this real quickly, you can see that using just the dimensions 1, it's only affecting the R channel. Just have to re-render this. There we go. And anything that is of a similar color is going to be the same size scale. So the dark reds boxes are all going to be larger in this case, and the lighter reds, I believe, are going to be smaller. So the more stepping size you have, the more variation between the sizes you're going to get. Or the wider the range in this case as well. Now, I'm going to unpack this because I really just wanted to make sure the colors were on the entire object, the entire piece for each one. So I'm going to unpack, and I'm going to transfer all my attributes back over. Now, how does this tool work? Well, it simply uses the UV layout node. UV layout node is genius because while it's built for UVs and efficiently packing, it can pack lots of things. And there's a good entanglement tutorial out there for using this tool. So the UV layout, if we change the UV attribute to P, it's going to fit them into a certain space. Now I'm going to change that projection to be ZX, so top down. You can see that with the top-down projection, it's fitting them as efficiently as possible, like a UV packer should. However, the one thing that we don't want is it's lost all of our rotations. So this could be for a cargo ship, for example, but not in the sense that we wanted a random rubble around a city. So the first thing we need to do is axis alignment. We need to make sure that their alignment isn't changing. So turning that off, it's going to have to repack for a moment. And now it's kept the original rotations from the scatter and align node. The next thing we need to do is pack into. So this is packing right now into rectangles, so a 0 to 1 square. And it's not using our input object. So if you look over at the second input, that is packing target geometry. So I'm going to reference this object output placement node. So I'm going to put down another object merge. Connect that in. And I'm going to drag and drop the object out placement node into object 1 and let that pack. Now you can see it's taking quite a bit of time, and that's because we're excessively packing these objects into a bit too much of a space. So I'm going to go back to UV layout, and I'm going to lower the resolution that this can pack at. So if I go to advanced, the search resolution, by changing this number, is going to change the accuracy of this node. So if we went to a very low number, it's going to pack as efficiently as possible, but it's going to waste a lot of space. Again, we just need to change this pack into islands from second input. Now, again, tool is totally broken, but it's because it's trying to pack UV. So we're going to pack position. So if we look at the object now, we're again trying to pack into our object merge, but it's packing from the XY projection. So it's using this face actually, which is really interesting. Now, at this moment, I've noticed I'm grabbing the wrong node. So I need to do this at out bottom layer actually. So I'm just going to drag and drop this. So you can see with the top down, we need to make sure our packing is from the ZX projection. So top down packing. So now we've fully filled our object that we've set. If I change the search resolution, we're going to get a bit more efficient, but it's going to take a bit longer. Now, a quick way you can speed this up is just attempt to pack less objects in there. So I'm going to set my scatter and align node, and I'm going to set this to a lower density scale. So now you can see changing these values, it's a lot quicker with how it packs. You can get some really unique object locations just by changing this max angle. So they almost all arc together. And you get some really interesting pattern shapes. I'm going to keep that at 360 for a bit. Now, one thing that we have to note is sometimes if you pack geometry into the space, you're going to have excess geometry you need to get rid of. Let's see if I can force that to happen. I'm going to go back up to my geometry at the very top, and I'm going to change the uniform scale to a larger number. Now, this doesn't seem to be doing anything. I'm going to add scale first to this. Let's see if that will force it. So we're going to scroll up to variable scaling. And you can see there's already an iScale value just turned off. So you simply just have to turn that on. So at this moment, it's because you can see in grayscale, I haven't changed the attribute randomized to be iScale. So I go to my attribute name, set this, and let's check the UV layout, invalid attribute specification. I think it's because the attribute is on the wrong data. There we go. So changing it to primitives has now allowed it to use the iScale value. You can see the same pink objects are being packed at different scales. It's perfect. And the stepping scale size had allowed stacking, the heights themselves actually almost stack up themselves. Like you can see it ascends like a staircase. So if we increase the stepping scale size, you're going to get less layers pretty much. If you had a very small stepping scale size, 0.25, you should have quite a lot of variation. Let's see if we can find it. Maybe not. It doesn't seem to be able to be forced. That's fine. You just have to believe me on that one. So I'm going to set this again, pretty small. Keep it at that value for now. So I'm going to go back to my copy to point, and I'm just going to quickly see if I can get more objects into the space. I'm going to set that density scale back up. Copy to point. I'm going to increase their scale at the start. So the very last thing for scale is I actually haven't turned off the fixed scaling. So right now, because again, such an efficient UV packer, it's working against us. So we need to turn off scale and to be fixed. There we go. So I'm just going to undo what I did there, and that's the transform value. So you can see as this transform value changes, this packer now tries to fit as many as it can into the space with the search resolution that it has access to. And the excess that it can't fit is now being in an overflow stack. Now, me being lazy, the easiest way to just get rid of this, again, is blast it away. And thankfully, the UV layout node gives us a couple different output groups. And straight away, it has non-packed polygons. So we can put down a blast node right after this. And I'm going to blast away non-packed. So straight away, we have our UV layout node packing and search resolution 1024 as many of those objects as possible. And you could expose that value right at the start of the uniform scale. You can see how efficiently it'll work. Changing that scale will change how much it can pack into that space. So that pretty much concludes packing the objects into a space segment. For the next episode, we will be looking at setting up vertical stacking. Following episodes, we'll look at simulation and Unreal instancing. See you soon.